guys. I hope you all are good and enjoying a good health and time. Guys, the topic what we are going to discuss today, that is finding this topic, the constant of integration. How can we find the constant of integration? You need to know about that. We can find the constant of integration by knowing any point on the curve, like we can be asked to find the equation of the curve if we know the gradient. Gradient means dy by df x gradient and the coordinate of a point on the curve. If you are given any curve, then you need to find the gradient with a point as we did before. But here the constant integration can be find it by knowing the point xy coordinate of point lying on the curve and the gradient of the curve. If they are given, then we can find the equation of the curve. Then what will be the y equal to f of x when dy by dx of this curve is dy by dx at this point is supposed to be given, say 1 4. Now, in order to solve few examples to help out to find the constant integration, let's see a question. You are given, question is find the equation of the curve given that gradient means dy by dx of the curve and a point, say P, on the curve. So here you can see you are going to find the equation of the curve when you are given dy by dx and a point on the curve. So think on this is, suppose you given dy by d of x is equal to 3x square plus 5x plus 2. The point is, suppose P is point in 1 and minus 2. So what we are supposed to find? We are supposed to find the equation of the curve whose gradient is this. Whose gradient is this. So whenever we need to find the equation of the curve whose gradient are given at a certain point, then we need to integrate this. And for integration, we need to make a separable function. Separable function means make dy y one side and all x terms on other side with dx here. And this is we can say it's a separable equation we formed by keeping all y one side and x on other side. Now what to do? Just take the integral on both sides. Here take integral and here take integral. And you know, if there is nothing between the integral and differential, they can cancel each other and we get y. So from here we get the variable y, and this can be split up by using the property. Let me write f of x plus minus g of x d of x. His integral will be, you know well, we need to split it. And first we take integral of f function plus minus integral of g function, and this is the process. This rule we already have discussed in our first video. So by applying this rule, this rule here, what to do? We will integral x squared d of x plus 5 goes constant outside x d of x, and here you can see as 2 is a pure constant, it will be taken out and only dx will be left. So what to do? We need to write y equal to 3 is a constant, it will be written itself as it is. So x square, so add 1 in the power, it will become 3 as per rule of integration. Similarly 5, it goes 2 by 2 plus 2 times x plus the constant of integration. Now as it's clear in the question that we are going to find the constant of integration, our point of interest is to find c, and c is lying the curve is lying at point P. So you can say at point P 1 minus 2, do replace x with 1 and y with minus 2. We will get minus 2 is equal to 3 times 1 power 3 by 3 plus 5 1 power 2 by 2, 2 times 1 plus c. I just replace all x with 1 and all y with minus 2 here in my answer of integral. So after simplifying, you can see 3 cancelled, we get minus 2 is equal to 1. 5 by 2 gives you 2.5 plus 2 plus 3. Minus 2 is equal to 5.5 plus c. Take this as a side. Minus 7.5 is the value of c. This is how we can find the constant of integral c. Now do replace this value here. Put this value here. What you will get when you substitute this value in the result, we get y equal to, as you can see, the 3 is cancelled, so x3 plus 5 by 2 x square plus 2x plus c goes to minus 7.5. So this is the final equation of the curve what we are looking for. I hope it is clear to everyone. Take another example of the same to find the equation of the curve with a given gradient and a point. Say we have another example. You are given the gradient of the curve, that's dy by dx 1 minus root x whole square over root x at the point P is 9 and 5. Let's see how to solve this. As it is clear, we are interested to find the equation of the curve. The question is find the equation of the curve whose gradient and a point was given. So what to do? As discussed before, we need to make the separable equation. So all y will be one side and x term on the other side, and it will becomes dy will here 1 minus root x whole square, and you know as this comes up, it becomes x power minus 1 by 2 and dx. And here we need to simplify this function before we start integration. So let's expand it. A minus b whole square identity, I'm going to write here a minus b whole square is a square minus 2ab plus b square. Here I will apply this identity. So it becomes a square minus 2ab plus b square root of x is x. And outside we have x power minus 1 by 2 d of x. Now to multiply this with this and this. Let's see what we'll get. We get simplified form of the expression dy x is to power minus 1 by 2 minus 2 1 is to be added. It's become x power 0. No need to write it. X power 1 by 2 and d of x. And we know x power, any power term with power 0 is always 1. So this goes to be 1. So now we can integrate this dy equal to integral of x power minus 1 by 2 dx minus 2, because this whole is 1, so no need to just write dx, plus integral x power 1 by 2 d of x. As per rule, integral and differential, if they don't have variable between them, so they will cancel each other. We get y is left. Here the function is x and its differential dx is along with it. To add 1 in the power, we get power 1 by 2. Minus 1 by 2 plus 1 is 1 by 2. Here divided by 1 by 2. Minus 2. This again goes. We get 2 and x left. Here add the power, it becomes 3 by 2 divided by 3 by 2. 3 by 2. Plus the constant of integration, that is c. So you are interested to find the constant integration to make your final equation of the curve. First, if you want to simplify, you can. This and this goes to be x power 1 by 2 2x plus 2 by 3 x power 3 by 2 plus c. At the given point P, that was 9 and 5 here in the question. You know, it was given in the question, it was 9 and 5. So do replace here y with 5 to 9 power 1 by 2 minus 2 times 9 plus 2 by 3, 9 power 3 by 2 plus c. Finally, once you will solve this on calculator, you can get c becomes minus 1. So replace the value of c here. Finally, the required curve, required equation of the curve becomes y equal to 2x power 1 by 2 minus 2x plus 2 by 3 by 2 plus c, that is minus 1. So this is the final answer. So with the help of these two questions, we have understood that how to find the constant of integration, that was c, by knowing the gradient dy by dx and a point on the curve. I hope this is clear. For the final touch of this concept, let's try another question. Question can be asked in a way that the function f is such that f of x is 15x4 minus 6x and f of minus 1 is equal to 1. Then find f of x. f of x, you know f of x is a function of x that is equal to y. So again the question is about to find the equation of the curve when you are given this differential. Sorry, it is f prime of x, right? You are f prime of x, we know this, dy by d of x is termed also in function of x, f prime of x, right? So we need to find the equation of the curve. Gradient is given to you, this one. So already it is in separable form, so integrate this f prime of x d of x will be integral 15x4 minus 6x d of x. So we know that integral of f prime of x d of x is equal to f of x. The reason this whole term represent dy by d of x, and this dx will cancel this, we get integral dy, that will be y, and we know y is a function of f of x, is a function of x, so we write it y equal to f of x. So here this whole result of integral will be given me, it will give me f of x, and here separated 15x4 d of x minus 6x d of x. So this is f of x, what we are looking for. As per rule of integral, 4 plus 1 5 divided by 5 this times 6 is become x2 by 2 plus c. Okay, now what to do? You can, if you can simplify it before, it's good. 2 1 2 3 otherwise you can let it be as it is, 3x5 minus 3x2 plus c, right guys? Fine. Now after finding the equation of the curve in term of c, we need to find the value of c. As it is given, f of minus 1, f of minus 1 was 1, it was given. So here do replace x with minus 1 and equate the result to 1. So we'll get 3 times minus 1 power 5 minus 3 times minus 1 square plus c equal to 1. What was given here? So it's become, after simplifying, we get minus 3 plus c will give me 1, and simplification give me 6 and 7. C is 7. So do replace the value of c in the function. After integral, we get the required line 3x5 minus 3x square plus 7. This is my final answer. As we are looking for f of x is 3x5 minus 3x square plus 5. I hope it's clear. Okay, good luck.